To find the sum of the first 30 terms of arithmetic sequence, we need to know the a value, and we need to know the common difference, and we need to know n. So in this case, n is given. The a value, we're starting at 100, and in this case, the common difference is going to be minus 6. Okay, so I'll just do that in a different color here. Our common difference from here to here, d is equal to minus 6. So to look at our formulas then, this one here, we don't have the last term, so it's probably better to use formula B. So we're going to use that formula, and the formula looks like this. It's going to be the sum is going to be half the number of terms, because we're going to pair up the first and last terms, 2 times a plus the number of terms, sorry, I'm going to keep that as a for now, 2 times a plus the number of terms minus 1, so that's going to be the number of steps. This n minus 1 represents the number of steps from 1 to n, and then times that by the common difference. And so we have all these terms to work with. So we're going to find S30. So the sum of the 30th term, or sum of the first 30 terms, is going to be 30 divided by 2, because we're going to have 15 pairs. We're going to use that first term. And there's going to be 29 steps from 1 to 30. So 30 minus 1, and then times the common difference. We go down by steps of 6. And there is our expression for the sum. So we just need to work this out. 15 times 200 plus 29 times 6. That's going to be negative 174. Okay, so we end up with 15 times, this ends up being positive 26. Okay, 15 times 26 is going to be 390. So the sum of the first 30 terms, or S30, is going to be 390. So there's 30 terms in this sequence. Some of them are positive, some of them are negative, and we sum them all up. We get a total of 390. For this one here, we've been given the sum of the first 30 terms. So we've been actually given S20. And so the S20 is equal to 480. So the first term, find the first term if the common difference is 2. Well, we know that the formula involves knowing a, d, and n. So if I just plug this into my formula, I should be able to just end up with one variable. So let's see what this looks like. So 480 is equal to n divided by 2, 2 times a, which is what we're looking for, n minus 1, so 20 minus 1, times the common difference of 2. And this should all add up to 480. And I can algebraically solve for this for the first term a. So I end up with 10 times 2a plus 38. Going to divide both sides by 10. So 2a plus 38 is equal to 48. Solving for a, subtract 38 from both sides. A works out to be 5. So the first term is 5 in this case. So a equals 5. So, what do we need to know when we're dealing with arithmetic series? Well, we have our Sn term. Okay, so that we need to know what Sn is. We have our n, the number of terms. This would be the total sum. We need to know the common difference. This happens to be our slope. And we need to know the starting value. Now, what we could also include in here is RL, because we do have a formula that involves the last term. So what's the difference between these two formulas? Well, basically this formula involves the last term. This formula doesn't involve the last term. And so when we have the formula when we have the last term, we can use the formula A. If we don't have the last term, we can use formula B. So we can generalize in that way. So basically, formula A involves the last term. Okay, and this allows us to pair up the first and last term. So we would use this one, use when L is known. Okay, so formula B uses the common difference. Okay, and we use this one when we know the common difference. So this is, okay, so A, we just stated here, when last term is given. And B, when we have the common difference. Okay, so this question here involves whether it's really just a self-check. Do we understand when we're dealing with a series versus a sequence? So a series is a sum of all the terms. The sequence is when we list out each individual term. So a series is when we add up all terms. A sequence is when we have a list of individual terms. And it's important to recognize when we're being asked for the sum of the sequence versus the sequence.